of all, thank you very much, COSMA, for its wonderful people being here. In fact, it is a very stressful time, but still I could see its full house in this link. I should say hats off to you, because it says that people are still interested in learning things in spite of being under stress. With a short note about me, my name is Hari Balasubramanian. I am in this industry since 28 years. No doubt I was working in India, the initial start of my career, for almost around 11 years. I used to work for companies like Alacrity Electronics. And then I have moved into Middle East for the last 16, 17 years. And I've been focusing on the power quality and energy management products. I've been working with companies like Landis+Gyr, Schneider Electric, and also with currently with Janitza Electronics. So this is the short note about me. Maybe I can talk about the company Janitza in short view, and then I can jump into the subject. I can assure you one thing, I will try to keep it as short as possible and also interesting. That's one thing I always take it as a challenge to do it with me. In case if you have any questions, we can always discuss it out during this, because IEEE 519 is fairly old standard with a new concept in India. So we will try to explain simply as much as possible so that we will be in a position to go through with the standard very easily. With your permission, all your permission, I'm just starting my presentation about the company. Janitza is a second generation family run business located near Frankfurt. It's somewhere north of Frankfurt. We are closely around 60 years of experience in Germany. We started our meter manufacturing somewhere in 1986 and named it under the company name called Janitza Electronics. So the best part of Janitza Electronics is we make everything within Germany. So whatever the product you get is 100% made in Germany product. We have our own production lines for PCB assembly machines, PTH, and also the solid state devices, and SMA components are all assembled within the factory premises. Our R&D development, software development, everything happens under the same roof, which means there is a good coordination is ensured between the processes of R&D to manufacturing to marketing, all come under one roof, and that's how we maintain our quality. We predominantly focus on three parts of energy management, or I can say measurements. We call it as energy monitoring, power quality, and residual current monitoring. So all the three manufacturing functions. Moreover, we are only doing meters. We don't do anything else, which means we can call ourselves expert, because all the time we are thinking about how the metering solutions or the measurements can be made easy for our customers. So that's how we have been, that's how our philosophy has been. We have a global presence in various regional offices. In the last 3-4 years, Janitza has decided to slowly move out of Germany and spread across the world, even though we have been supplying to various places all over the world. We started having offices in USA, Ireland, UK, UAE, Russia, Austria, and soon we will also be available in India. That's the plan for the coming year. And then we also have a complete partner network who can help you all in giving the right solution from our products. So that's how we go about it. That's about Janitza in short. We have quite a lot of customers, ABB, lot of automobile manufacturers in Germany, data centers. We can name every electrical user is using our instruments. And what you see here predominantly are data centers. We are also providing solutions for data centers exclusive for some of the data centers. So that's a That's a short about our references, but we are there in every segment for critical power, manufacturing industries, utilities, infrastructure, commercial buildings, retails, hospitals where RCM can be used, because in hospitals, residual current monitoring is one of the subject which people have to use for better understanding, to avert accidents and to being safe. We also supply some of our products in marine as well. Coming to India, we have quite a few customer base in India I've just listed a few of the customers in various segments who have been using our products for more than 5 years. So these are some of the customers list who we are having it in India. And coming back to the subject, I wanted to give you some information on the basic power quality parameters before we go into the standard. What are the power qualities parameters? We can call it as sag and swells, harmonics, flicker, unbalance, frequency fluctuations, and transients. All these parameters have three things in common. That is the time, duration, and the depth. The time is what time it is happening. The duration is how long it is happening. And depth is what is the magnitude it is happening. Say if it is an under voltage, how low the voltage is going or how high the voltage is going. If it is a harmonics, again, how much of harmonic is high and low. And what is the duration of this particular harmonics. If it is continuous, or if it is for a short time, or if it is for a longer time, all those things have to be calculated. So it's very important in power quality parameters to understand time, duration, and depth. So that's how the whole thing is represented for power quality. I'm not going deep into the power quality parameters because power quality as a parameter is being talked about in India, to my knowledge, at least since more than 20 years. But now I understand it is very good that India is moving towards some standards of power quality. So I will take some essential power quality standards and try to discuss it over here. The first one standard is called as IEC 61000-4-30. The second one is called as EN 50160. And the other one is called as 61000-2-4. And the last one I wanted to discuss is also about IEEE 519. And that is in India, as I speak to many customers and consumers across India, IEEE 519 is still a mystery for many of the consumers, even some utilities would like to implement, they do not know how to do it, what to do. So the process of us today is only to lighten it, to make a glimpse of how it can be done. For a continuous uptime operation, the compliance to these standards becomes very important with respect to the power quality, like harmonics, current voltage and balance. So most of these standards talk about these parameters like voltage dips in short-term over voltage interruptions and flicker and phase shifting. So this is all the standard which are available. And Janitza is also helping customers in making these standards easy for the customer to understand. This is what is very important point, which I wanted to get it across. If you look at the standards, there is a distribution company which is delivering power to the consumers. And there is a point of common coupling where they transact energy. That is, the distribution company is shaking hands with the consumer and giving power and to the consumer, and that point is called as point of common coupling. So in essence, the standard EN 50160 is to be maintained by the utility. So generally, if a utility says I am maintaining an EN 50160 standard, then it means they say they are giving a good power frequency, they are giving a good quality of power without sags and swells. There is no voltage change. The flicker is less. There is not much of voltage unbalance, and voltage unbalance is within the limits of EN 5160. And harmonics for the voltage up to 40th harmonic is maintained according to EN 5160, and of course interharmonic voltage. So when the utility says that EN 5160 is maintained, it talks only about voltage. If you look at it, it talks about only about voltage. And then the IEEE 519 comes and says, look, consumers create current harmonics. Because of current harmonics, the voltage can get distorted. And that voltage, so it is a shared responsibility of the utility and the consumer to maintain the power quality in terms of IEEE 519, which means harmonic currents is the responsibility of the consumer. The voltage is the responsibility of the utility. So it means it's a shared responsibility between the utility and the consumer. So now we know when the consumer gives so much of harmonics, it naturally distorts the voltage. And the same voltage is supplied to the other consumer, isn't it? On the same bus bar or on the same line. So which means the other customer who is not generating harmonics, but he is getting a distorted voltage. So that is why the utility should manage not only to support the customer who is generating harmonics, plus also to adjust their system impedance in such a way that they don't transverse the same voltage quality to the other customer. So that's a, there is a thin line of difference how they will have to handle this particular issue, because it's a shared responsibility. That's what IEEE 519 says. Now, to do all these measurements, there is a base standard called as IEC 61000-4-30. We call it as Class A Edition 3, which is a testing and measurement techniques of power quality measurements. So which means when you wanted to monitor and measure power quality, there is a particular standard which tells, look, you should use a meter which complies to the standard, which means 2 meters with same configuration complying to the standard will give the same result, because measurement of harmonics by the meters or by the meter manufacturers is typically a complex process of algorithms. So just to create the uniformity in the algorithms, the IEEE 519 is done for 61000- according to 61000-4-3, especially the meters. So that's what this talks about. This is if you go through it, whatever I have said, it is on this particular slide, it is very informative to give you a very clear line of understanding on how this. I will be, most of the time, I will be going through in the following slides as well, the same points to make sure that we all understand perfectly. In the meantime, CEA came up with a regulation in India. I'm just taken the small paragraph hint, which says the customers should measure, or all the consumers of high voltage should measure current and voltage harmonics at the point of common coupling, complying to IEEE 519 standard, using the 61000-4-330 Class A meters, and they should install all the power quality meters in the point of common coupling. So this is what CEA regulation has given a guidance to all the utilities in India. So it is, again, the voltage and current limitation is given in the IEEE 519. CEA has mandating all the consumers to use a 61000-4-30 Class A meters. And then they ask the consumers to monitor the compliance for IEEE 519. This is what in a nutshell CEA regulation talks about. last year by end, Maharashtra State Electricity Regulator came up with a supply code for standard performance of the performance of distribution licensees, including power quality. So they have given a supply code 2020, and which indicates that all the licensees, that means discoms, like whatever the power companies like Adani or Tatas or even Maharashtra state distribution companies, should follow certain amount of power quality conditions to be compliant with them. Like, for example, they have very clearly stated that you can have 10 to 20 milliseconds of disturbance of up to 90 to 80%, 30 times in a year. Or they have said you can have 5 to 600 milliseconds of disturbance of as low as 40% to 5% to 40% of the nominal voltage 5 times in a year. So the rules for the utility distribution companies are getting stringent, which means we will have to measure it. If you can't measure it, we can't improve it. That's what Lord Kelvin says. So it is for the benefit of the consumers that they start using the right product and start measuring it and keeping a record of these kind of information. So this is a very important factor that to be considered when choosing your products while giving it to your customer as a panel builder. Further, it also states, the supply code, it says that limit of current harmonic injected by designated consumers shall be in accordance with IEEE 519. So there is a limit on IEEE 519 which has come up. So I will be taking into what are the limits in the next few slides. The designated consumers shall install power quality meter at the point of supply and share the recorded data thereof. So they have asked us to have a power quality meter at the point of supply, and then we should start monitoring it. These are all for good for the consumers, because when the power quality is maintained reasonably well, naturally the production losses reduces drastically. Currently, our production losses due to the power quality in India is very huge. In fact, there was one report which says it runs out in few millions of dollars. In fact, thousands of millions of dollars. So that can help us. We could have the right gadget or the right measurement to make our power quality better. It is a contribution from the consumers towards the better power quality from the utility so that they can demand. So that's how the whole question goes on. So the measurement undertaken or to determine compliance shall be carried out in accordance with 61000-4-7 and IEC 61000-4-30. So this is a very clear mandate coming from supply code of MERC as well over here. Now, I wanted to slightly touch upon what is 61000-4-30. The 61000-4-30 is the standard which defines how the measurement of power quality should be done, which defines clearly the algorithms, how the sample should be taken, how the measurement should be done, how the calculation should be done in the meter, and then the data should be presented. So the standard clearly defines under two categories, Class A and Class S. Class A is more of a specific standards, and Class S is more or less is the declaration. People can declare this is why I'm testing it, and then they will get Class S. But Class A, that is why I said when Class A meter is used, when two Class A meters are used with same configuration at the same point, then the readings would be more or less the same value which you would be getting it across. So Class A becomes mandatory for legal compliances. So because Class A is the one which tells us how these measurements are done specifically for every parameter. And then Class A standard must meet the high performance and accuracy requirement in the standard. So all the instruments has to be very reliably, and then it has to have a standard way of calculating the parameters and giving it out as per the standards. This includes the various power quality parameters like sag, swells, frequencies, harmonics, flicker, etc. So it talks about almost all the parameters, and there are new parameters in the latest edition as well, which is called as edition 3. So they were talking about Class B standard, which is not in vogue now. That standard is closed, I think, way back in 2000. I think it's somewhere in 2008. That is gone. Class B standard is no more available. That's why I have given it a strike it out over here. And I don't think we can get a meter with Class B anywhere now because the standard of Class B do not exist. Then the EN 5160. If you look at what the reasons of giving about MERC, which has given about the voltage levels to be maintained, including sag and swell, it all complies with EN 5160. So they talk about frequency, voltage magnitude, waveform, how it has to be, and then an unbalance in voltage and all those things. Generally, these standards do a statistical evaluation. That's what is very important. They do a statistical evaluation and then present you with EN 5160. So you cannot take 1 day reading or 10 minutes reading and say that I'm complying to that particular standard. It has to be with respect to over a period of time. So EN 50 talks about generally a 1 week data, what is collected, and then it is done. The same standard, another standard which is predominantly accepted towards the load. Say, for example, a VFD manufacturer could say that I am complying to 61000-2-4. So this is coming towards the load. When they comply to a certain amount of current harmonics towards the load side, it is not at the point of common coupling, but it is towards the load side. So they may comply, suppose, for example, if you're using a multiple variable frequency drives, those variable frequency drives may comply to 61000-2-4, but not essentially comply to EN 5160 or IEC IEEE 519 at the point of common coupling, which is at the incoming of the main gate of the power where we buy the power. So it has to be very clearly understood that 61000-2-4 is a standard which is used towards the load side, and then IEEE 519 is used as at the point of common coupling, which is where the point of purchase of power from the distribution company by the consumers. Now, I am just taking you into a travel towards inside the IEEE 519. The standard is widely used in Australia, now in India, USA. It recommends a good practices. It gives a good limits. It supports the consumers who are generating harmonic itself because they know lot of loads are going a high frequency loads, switching loads, which means that can be high amount of harmonics which is getting into the system. At the same time, supporting the utilities that consumer should take the responsibility and utility should monitor the voltage harmonic distortion from their side as well. So that is why CEA also mandates that distribution companies should have power quality meters in their outgoing feeders itself, in their distribution substations. So that's another subject as of now, which is completely going on. Right now, TDD is a parameter which is introduced in IEEE 519. What is TDD? TDD is basically the total current demand distortion. Generally, THD is calculated with respect to fundamental frequency, whereas TDD is calculated with respect to the load taken by the consumers over a period of time. So it means the reference for harmonic measurement is adjusted or made easy by IEEE 519 by measuring TDD for the consumers. So that's a very valid point. And this they call it as, you know, calculated harmonic distortion against full load level of the electrical system. Say, for example, if a consumer is having 1000 kVA load, and it's the current for the 1000 kVA which is used in the last 12 months. So they have said, even if you may have a higher load, higher contract demand, but still you can have a lesser amount of demand what is happening in your network. So maybe you can take it for the last 12 months and, you know, calculate the total demand distortion. So this is another point which is coming up on the power quality standard IEEE 519. Now I'm going to take you to how the standard asking us to do the measurement and how the statistical evaluation is done. It is a very interesting point. The standard IEEE 519 is asking us to measure readings for every 200 milliseconds and average that, aggregate it over 3 seconds and put it in one box as I present over here. And then these 3-second value is evaluated daily for a 99 percentile of limit. So it means you will have roughly around, in one day, 28,800 samples of data for individual harmonics, say 1 to 50, plus TDD, and asking us to collect all the data and putting it down for daily evaluation purposes with against a certain limits. So this 28,800 data collected, say for example TDD, is sorted in certain order, and then the 99th percentile is found out, and then that limit is cross-verified with a table which is given in the standard. So it is pretty complex to do when you wanted to do it over an Excel sheet, because as I said, you will be doing it for 28,800 for TDD, individual harmonics for 1 to 50, which means for individual phases. So that is 150 parameters, and then the TDD is 3 parameters. So you will have 153 parameters of data managed for 3 seconds in a daily value, and then you will have to do the calculations, which is pretty tough to do it. And that is where the meter manufacturers come in handy to help you out in this case. The second option is the 3 seconds data is assessed over 10 minutes interval and aggregated, and then that is used for weekly evaluation of 99 percentile for a limits. So you can understand that is one way is daily evaluation, and another one is a weekly evaluation, and they have given for 99 percentile for a limit specified in the table. Wow. It also says another way. It says that the same 10 minutes interval for over a week is also assessed to over 99 percentile limits. So there is a limit for daily evaluation, 99%. There is a limit for 99 percentile for a weekly evaluation. There is a limit for 95 percentile for weekly evaluation. So because why they have given these 3 kinds of evaluation, because different load conditions, they can have different kinds of harmonic injection. Say for example, a foundry plants can have a very high changes within the 3 seconds, but their limits are high, very high for 99 percentile limits on a daily values. Whereas a textile mill, for example, can have a more or less a steady values where we can evaluate it for 95% or 99 percentile on a weekly basis. So this is just a evaluation technique. There are 3 evaluation techniques which is given for harmonics and as per the defined tables. Now, for different voltage levels, these limits are specified. Say, for example, if a voltage level of a customer is 400 volts, or if a voltage level of a customer is 11 kV, 33 kV, 66, and maybe up to 110 kV, we have different voltage limits. Then the limits are specified for individual harmonic frequencies as well. So which means we also know that limits are specified for third harmonic, fifth harmonic, 7, 9, 11, and then 13, but also for even harmonics as well in the whole picture. So it means it is a complex calculations which we will have to go through. Then they say that ISC by IL ratio, depending on the point of coupling, location of the point of common coupling and the impedance over there, which means it has a possibility of adjusting the values according where the customer is in the network, whether they are very close to the substation or the transformer, or the far away from the substation or the transformer. They have also, the limits can also vary. So there is multiple levels of considerations which are given so that customers can accordingly have their harmonic can be generated accordingly. So it becomes a calculation which has to be done before we start actually complying to IEEE 519. ISC is again calculated at the point of common coupling and not at the substations, not at the distribution substation. So it is at the point of common coupling where the utility is giving power to the consumers. So IL is basically the last 12 months average peak current. I will also show you how this limits can help us. In short, at the point of common coupling, we need to determine our ISC and the 12 months average maximum demand current, and then we will have ISC by IL values, and then that will be compared onto the table. I will show you the table on the next slide. When we do this, and when we have the ISC by IL value, then we have a legal framework with Class A meters to give the utility that whether we are complying within the standard of IEEE 519 or not. And that's where Janitza also helps customers in creating a very conducive environment of understanding about the IEEE 519. If you look at it, the limits are actually basically done like that. For the voltage distortion, for every voltage level, we have an individual harmonic percentage what is created as a table. For current as well, for example, I have put a current distortion limits for one table of current distortion limit from 122 kV, 122 volts to 69 kV. Here on the right side, you have the ISC by IL value. And then you have the individual harmonics, 3 to 11, 11 to 17, 17 to 23, 23 to 35, and 35 to 50. So according to the ISC by IL ratio, your limits are defined. So it is very clear. For example, if a customer is having an ISC by IL value between 20 to 50, then his third harmonic can be up to 7%. Whereas the same customer, similar customer who is having an ISC by IL value at between 50 to 100, he can have a higher level of harmonic. Say third harmonic can be up to 10% as per the table. So it's very, very clearly understood, has to be understood that what level it has to be. Same way for the total demand distortion as well. So for the lowest allowed is 5. The highest allowed is up to 20, depending on the ISC by IL value, which means calculating the ISC by IL value for all the consumers plays a crucial role in determining their TDD values and the harmonic limits. This is one part of it. As I said, there is a 3-way of calculation of 99 percentile, weekly 99 and 95 percentile. For that, these limits has to be applied according to either 1.5 times this table value, or one time the table value, or 2 times the table value. The table value is according is statistically evaluated according to the weekly or daily and then the current limits. So it's a very complex process what we understand right now here, how this whole stuff works. So it's a very, I would say it's a very high challenge for everyone to do it. That is where our power quality meter, when you choose, you should have certain amount of information how you wanted to do the measurement and what kind of specification it should have. So the first one is, as Shrikant just talked about, UL, the product, we have a UL certification as well. Has to be UL certified. 61000-4-30 is a standard which needs to be type tested for. That is a requirement for a power quality meter. And then, of course, there are other standards like 62053 and CE, which is all the normal safety regulation comes in. It's easier if you have a good display on your meter where you would be quickly able to understand, and enough memory, because memory has to be enough in the meter to show you that value of data what you have. It is not the size of memory that matters. It is more than, it is how the memory is managed and how long you can have the data inside the memory for. Say, for example, if I have my iPhone today, if I have a 32 GB iPhone, I may not actually have the liberty to use all the 32, because already 12 GB of data will be from the operating system. So then there is no, I can't even say that it is still 32 GB of memory. But what is the exact available useful memory and how long the data can be stored is what needs to be considered while choosing a meter. And then there are a lot of communication possibilities has to be kept open in the devices so that the data can be transmitted to a different system. Of course, there are other measurements like voltage, current, and power factor, and all the measurements which can also be done over here. So I will give a short checklist for what is required for IEEE 519 monitoring for the consumers. So the meters have to be permanently on the PCC. The ISC value should be calculated. IL to be recorded on a monthly basis. ISC by IL value should be determined. And this IL should be configurable in the meter on a monthly basis so that the TDD is calculated accordingly. The compliance to be recorded for daily 99 percentile, weekly, and 99 percentile, preferably on the meters. Because generally what happens is if you do it outside the meter, then you always have the liberty to play around with some data. So it's always the possibility to, it's better it is done on the meter itself. Now I'm just taking you to a very short introduction about our meter given the opportunity. We have a product called UMG 512 Pro, which is a Class A Edition 3 approved certified meter by NMI Laboratories from Netherlands. It can measure 10 milliseconds, 39 microsecond transients, which means roughly we have around 512 samples per cycle on a 50 Hertz network. We can do a flicker measurements. It has an accuracy of 0.2 S class. Modbus, it can have a Modbus gateway. You can have a Profinet or even BACnet, for example, if you wanted to use it with your building management systems. And it also has an Ethernet port, which complies to FTP, SMTP, SNMP, and COM-trade formats. Memory is around 256 MB. Our usual factory memory recording is allowing almost around 6 months of data inside the meter, a standard configuration. We also can measure residual current with these meters. So we provide data information on all the three aspects of measurements: power quality, energy management, and as well the residual current management in the meter monitoring. And then we also have 3 ways of seeing the data from the meter, which means we can have a graphical display. You can have a graphical spectrum. You can have a waveform on the display. You can have 3 years of monthly consumption on the display of the meter. So these are some of the display which I can take you through in the next slide. And then there is also a possibility through web service on the meter. So by typing the IP address of the meter, you can access what you want to do in the meter, because it's very difficult to show many compliances of standard on the meter. So what we have done is we have created applications inside the meter, like our mobile apps. We have created an application inside the meter where it can give you compliance to those particular standards, because quite a lot of calculations and statistical evaluation needs to be handled by the meter. So we do that through a application, and then it can be viewed through the web service. I'll try to show you how it will also look like. And then of course, once if it comes to the software, we can have all the customized dashboard data viewing and the energy reporting from the meter, because you transfer the data from the meter to the software, and then you can create much more possibility of reports and dashboard viewing. Quickly, I can tell you how the display looks like. Some of the pages of display I have just put in over here. Maybe I will also show you a live meter now, which is just behind me. In the process, these are some of the displays. You have voltage, current, all in summary page, and current for a particular parameter. You can have real power. You can have a monthly energy values for 3 years on a monthly basis, or a bar graph. Individual harmonics as percentage for voltage and current for all the 3 phases, both absolute and percentage. In essence, generally the harmonics is not told in percentage. It is generally told in absolute values, which is available in our meters. And then we also have the transients, which can be captured, and then the waveforms can be seen, plus also the oscilloscope functionality for all the voltage and current waveforms. I'm just taking you through the web page, which can have you the information. And this is a very clear IEEE 519 compliance analyzed. It very clearly tells for a weekly, you can have reports for a weekly basis. And then you have daily compliance norms from Monday to Sunday. So first to 7th day of a week, and then on a weekly compliance for 95% and 99%. So and then it also gives which frequencies are going away from the standards. So it is very, whatever I have said in the last 30-40 minutes is put in one page over here in our IEEE 519 application. That's what we do it. In short, I just wanted to go to my other screen to show you how this device would look like. I'm giving you information from a live device. Hopefully you're able to see. This is a device just behind me. I have configured it to be working as if it is working on 11 kV. You could see various parameters. I'm just moving the display by pressing the button over there, real power, and then the active energy. You can have the 3 years of monthly energy values, say 2019, 2020, and 2021 from the meter display. And then you can have the voltage harmonics as absolute values. And then if I wanted to see for the other parameters for the other phases, or if I wanted to see for the current, or I can see for the different currents. The next way is seeing the voltage line writer or a current. This is how my currents are going on over here. And then you can also have the transients. Whenever it is occurring, you would be in a position to see those values entered. You could see a transient on the voltage and current over here. That's a possibility. And then you can have, you could see events. You could see the phasor diagram, which is very important for any commissioning engineer to see how things are happening during the commissioning stage. And then you can see a waveform as well, how the current and voltage waveform is behaving. Yeah, so this comes up accordingly and also according to flicker. So in fact, Janitza is also working right now on IEEE 519 compliance on the meter display also. So that's the second phase which we are doing out. Maybe by next month, we should be having that as well on the meter. The meter will tell you whether the weekly compliance and daily compliance is happening on the meter display itself. Further, we can also see other parameters like graphs. If you wanted to see an online graphs, we would be in a position to choose and see the online graphs for the meter, where we will be able to see the online current which can be coming on. Even the historical values for the basic parameters for analysis sake can come in. I can also show you some of the power quality standard, what it is, watchdog IEEE 519. For these, I still installed, I have it for 2 days. That since I'm using a single phase supply, it can be wrong, but the essence what I wanted to show you here is it is a THDU, harmonic voltage, TDD, and harmonic current. And if I wanted to see where my failure of harmonic phase voltage, harmonics voltage is failing, is basically on a daily basis over here is somewhere, it is not failing, it is just going into, the red line is here. So it is not going down. So, but it is not 100%. So that is why it is showing an orange, but still we say there is this, the standard is getting passed on the daily basis. And then we have this information of individual harmonics. So this is how the IEEE, where you will also write your nominal voltage, you will also insert your short circuit current, your load current, and then the ISC by IL value is calculated. Accordingly, your compliance is tested in the meter and then given as a web page for you. That's another about this one. Now I'm coming back to the presentation just to give a short summary. Whatever we have been talking, we have been doing meters from power quality meters to a simple energy meter, comprising to do various energy monitor management, power quality, and residual current monitoring. You can choose the meter from our portfolio according to your applications, so that you get enough of information, because we don't believe in having the same meter all through the network and doing the same readings. It doesn't make any sense, because every level of monitoring, every level in the network requires a different set of parameters to be monitored accordingly, so that we can manage the system better. Say, for example, in one of the cases in Middle East, a customer, after 3 years of using the facility, they wanted to have a particular power factor trend of the information. Then they realized that meter is not having a power factor itself. So then it's very difficult for them to understand the power factor when they have operated the plant without noticing the power factor as a parameter. But when they wanted the data afterwards, they don't have, because they have the same kind of meter all through their network, which becomes complex for them to understand their own systems. So that's a point which I wanted to take it across, that every point of in your network requires different sets of meter according to what you wanted to monitor, and different places has to be with different values. That's why it will help the customer very much effectively on the long run for him. This is just a panel which is mounted with some meters just for you to show how it is. It is not only in HV panels, we also offer meters for lower levels as well. Plus, we also have our grid-based software, which can be used to communicate with any kind of devices, and then we can have it with a very intriguing information about your electrical networks through Sankey diagrams, through heat maps, through KPI bar graphs, where people can very understand their electrical system better and take appropriate action. So I think I'm just finishing off with information, what I have to give it to you today. I'm open for questions. And in case if you have any questions, I'm there. Messung is also available for further information. We will be happy to share with you the required information, what you want. So thank you very much. and I'm open for question. And again, I have to stress this point with the state of condition, with the stress we are all in. Thank you for attending this in full house. And I thank you very much on behalf of Janitza Electronics. Thank you.